Good everyone, my name is Graphics. Today we want to study an aspect of electrical engineering science which is called resistance. Now, when you say resistance is a force that opposes the flow of what? Of electron in a conducting material or in a conductor, right? And we have some element that offers resistance, and one of those elements is called a resistor, right? And there's one fascinating thing about a resistor or a resistance is that when electrons are being resisted to pass through a conductor, heat is being dissipated, right? Now, there are some factors that affect the resistance of a conducting material or the resistance of a material. And one of those factors is the length of material. We know that the longer a material, a wire, the bigger the resistance. So we say that the resistance is directly proportional to what? The length of a material. Now, the next one we're talking about will be the cross-sectional area. Now, we also know that the cross-sectional area is another factor that affects the conductivity of a material. When I mean cross-sectional area, I mean the thickness. For instance, now, if I have a wire this way, or a conducting material this way, and I section it this direction like this, looking at this direction, I'll be seeing something like this, right? So the thickness is called the cross-section, the area of the cross-section, right? So we say that the resistance is what? Inversely proportional to what? The area, proportional area of what? Of the material. So the bigger, the thicker the conducting material, the smaller the resistance, and the more smaller the conducting material in terms of what? Of thickness, the bigger the resistance, right? Now, if you look at this, if you combine these two together with the knowledge of your variation in mathematics, we can recall that this is a joint variation. So we can recall that our resistance is inversely proportional to what? To the length, to the area, and directly proportional to what? To the length. So we say that my R, the resistance, is proportional to what? The length over what? Area. Now, if I remove my proportionality sign, I'll be having the resistance is equals to what? The constant, which is called resistivity, times the length all over what? All over the area. So this is the general formula. The formula for what? Calculating for what? The resistance, right? Where R is giving us what? The resistance, right? This is called the resistance in ohms. This is called the resistivity in ohm meter. Then this is the length in meter, and this is the area of the cross section. Now, the third one, which is the temperature of the material. The temperature of the material. Temperature of material. Now, the temperature of the material plays also a vital role in the conductivity of the material, because the higher the temperature, the the higher the resistance of the material. And this is as a result of what? When the temperature of material is being increased, the electron in the material start bombarding with himself and with the wall of what? Of the conductor, right? So the higher the temperature, the higher the resistance, the lower the temperature, the lower the resistance. And there are some formulas that we need to be familiar with in order to calculate the temperature, the resistance, the temperature of the material, the resistance in the temperature of the material, right? Now, one of those formulas that we need to be familiar with is that we know temperature and resistance has a relationship. And the relationship is in this formula here. We are saying that the resistance at a particular temperature T is equals to the resistance at 0 degree, or the initial resistance, multiplied by what? 1 plus what? The resistivity at 0 degree, the initial resistivity, multiplied by what? The temperature, right? And also, we also have that the resistivity at temperature T is given as the resistivity at 0 degree all over 1 plus what? The resistivity at 0 degree times what? The temperature T. That's another formula we need to know. Now another one is the specific resistance at temperature T minus the specific resistance at 0 degree, right? Into bracket 1 plus resistivity at 0 degree multiplied by what? Temperature T. So equals to what? Equals to 0. And last but not the least, we say that my resistance at a particular temperature is equals to what? Resistance at 0 degree into bracket 1 plus resistance at 0 degree T plus beta at 0 degree T square. That's what we're having here. So these are the things you need to know on the temperature of the material. We'll solve some calculation in this to see how we are going to apply these formulas. Now, the last but not the least, we have the nature of the material. The nature of the material. And these have to do with what the conducting material is made of. So what's made of the conducting material determines the resistance of the material. If the material is made up of a conductor, or of a silver, or is made up of a tungsten wire or a platinum, you know that the conductivity will be different. So the nature of what? Of the material is another aspect we need to consider. Now let's take this example and let's see how it goes. Example 1. It says a coil consists of 2,800 tons of copper wire having a cross-sectional area of 0.8 millimeters square. The mean length per ton is 800 centimeter, and the resistivity of copper is 0.02 micro-ohm meter. Find the resistance of the coil. Now the solution here. Before you say you want to proceed in solving any question in any calculating course, you need to write the parameters of the data given. So the data given here is, it says the coil consists of 2,800 tons. So my number of ton N is equal to what? 2,800, right? Now the wire having a cross-sectional area of 0.8 millimeters square, so the area is given as what? 0.8 millimeters square. And the mean length per ton is 800 centimeter. Let's say L subscript N is the mean length per ton, and that's giving us 800 what? Centimeter. Now the resistivity of copper, that is this, is given as what? 0.02 micro-ohm meter. Now we are told to look for what? The resistance. We're told to look for what? The resistance, right? Now we know very well that we need to make the unit conform, and they should all be in meter. So if I'm converting 0.8 millimeter square into meter, it will be 0.8 divided by what? 1000, right? Square, then meter square, because of the square here. And this will give me 0.8 over what? 1 times 10 raised by what? Minus 6, which is 1 million. 1 times 10 raised by what? 6, sorry. 1 times 10 raised by what? 6. And when you divide it by 1 million, this will give me 8 times 10 raised by what? Minus 7. If you divide that, right? Now, meter square. So if you divide 0.8 over 1 million, you have this. And this, converting centimeter to meter, you have to divide by what? By 100. So 800 all over what? 100 will give me 8 meter. Now, the next one, we have 0.02 farad, right? And that means 10 raised by what? Minus 6 ohm meter. So we're going to calculate for what? The resistance. What is just trying to make us understand here is that we have a coil, let's say a solenoid here, and something like this, and there's turn. Turn means windings. Windings. So it's being wound around the coil, right? So we know that we are given the mean length of the turn per turn. At every revolution, it is what? 800 centimeters is 8 meter. So what will not be the length? So our length here will not be equal to what? Our mean length multiplied by what? Our number of turn. So my length here will not give me, what is the mean length? Mean length is 8 multiplied by what? The number of turn, which is what? 2000 what? 800. And this will give me 400 meter. So we apply it. So I'm going forward, and you write recall. Since we have to calculate for resistance, our resistance is equal to what? The resistivity multiplied by the length all over what? The area, right? And this will be giving us resistivity here. My arrow here will not. Resistivity is giving us what? 0.02 times 10 to the power minus 6. 0.02 times 10 to the power what? Minus 6 multiplied by the length, which is 22400 all over the area. The area given is what? 8 times 10 to the power what? Minus what? 7. Now if you do this in your calculator, you're going to be having 500 and what? 60 ohms, because resistance is measured in what? In ohms. So that will be my what? My answer. Now let's take another example. Now the next example says that a resistance of the silver is 1 ohm meter or 1 omega, right? What is the resistance of copper if the length of the copper is 1/3 and the diameter of the copper is 2/3 of silver? The resistivity of copper is 60 times that of the silver. So let's see how it goes. Now, like I said earlier, before you do anything, you have to write out your parameters, right? So the data given here, our data given will be, we say the resistance of copper is 1 ohm. So we say that my resistance is equal to what? 1 ohm, right? But what is resistance? Recall R is equal to what? Resistivity multiplied by length all over what? All over area, right? So it means that what? My resistivity multiplied by what? Multiplied by length, right? All over what? Area is equal to what? Is equals to 1, right? Because R is 1, so everything here is my R, so this is equals to what? 1. So but area is equals to what? Pi d square all over what? All over 4, right? So if I place this here, I'll be having resistivity multiplied by length all over what? All over what? Instead of writing my area, I'll put pi d square over 4 equals to what? 1. Now this will come up here to multiply this. So I'll be having 4 resistivity multiplied by length over what? Pi d square equals to what? 1. So this is what you need to put into consideration, right? So let's move forward. Now we move further. We are now told that the length of copper L, is equals to what? 1/3 of the length, right? And diameter of copper D is equals to what? 2/3 of the what? The diameter D. Are we good? Because given the question. So 2/3 diameter of silver. That says the resistivity rho is giving us what? 60 times that of silver. So 60 is the what? Resistivity. Are we good? Now let's move forward. So if you now recall my resistance R, so I'll use prime here to separate it from the initial one I used earlier, is equals to what? Resistivity prime multiplied by length prime, just to differentiate from what I've used earlier, all over what? The area, and I'll put prime here, right? And this can also be written as saying 4 resistivity prime, the length prime, all over what? By d square. Is that taken? I showed you how I got this earlier. Area is what? If you check what I've done in the past, like in this scenario here, I say the area is pi d square over 4, and when we have this, the 4 will come up and we're having this guy here. So we move forward. Now let's start putting our value. Now what is the resistivity? Is 60p. So we have 60p, 60 resistivity, right? And there's 4 here. 4 times that. Then the length is giving us what? 1/3 of the length multiplied by what? 1 all over 3L. Then all over the pi. Then diameter is what? 2 over 3 d square. 2 all over what? 3. 2 over 3 what? D square. So if you move forward, this will be giving us. Now if I separate this, I'll be having 4 times 60 resistivity multiplied by 1 all over what? 3 of the length all over pi. 2 square is 4, 3 square is what? 9. Then we have d square. So if I separate this, now let's do this. If I separate this 9 will come up, right? So I'm going to be having 4 rho L, right? All over what? Pi d square, then multiply by 60 times 1 all over 3. So I brought these 3 together, all over what? Multiply by 9, you have 4 here, times 4. What I did is I separated the all together. So 3 can go in 9. How many times is 3? 3 times 60 is 180. So I have 4 this times L over pi d square all over 4 times what? 3 times this is what? 180. Right? So 4 can go in 180, that will be 45. So we have 4 rho L over pi d square times what? Times 45. Right? And this will now give me, now recall 4 resistivity times L over pi d square will give me R. If you look at what we've done here in the beginning, it give me R, right? And what is that? That is 1. So, and that will be equal to what? 1. So I'll say that therefore my resistance will be equal to what? So the resistance will now be 1 times 45, or equals to what? That will give us 45 ohms. So if you have found this video helpful, don't forget to click on the subscribe button. Thanks for watching.